Okay, today we're going to look at graphing quadratic functions, and we're actually going to start with the parent quadratic function. And the reason I call it the parent is because it's the mama of all quadratic. It's the mama of all the parabolas. So, and it's the most basic one you can have, y equals x squared. It's kind of like y equals x for linear when it's y equals mx plus b form. So, what I did is I'm going to go ahead and fill in your domain that I have here, and then what we're going to do is we're going to plug these in and see what happens when we square. So really all we're doing is just taking these x's and squaring them. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the result is a square. So when we graph this, come over here real quick, we'll graph each point. Negative 3, 9 up here, negative 2, 4 here, negative 1, 1, 0, 0, 1, 1, put that one back there better, 1, 1, 2, 4, and 3, 9. Okay, and then when I connect those, it makes that nice, pretty parabola that we're used to seeing. Now, a couple of things about the quadratic is this point right here is called the vertex. So, and the vertex for the parent is always at 0, 0. Also, something you need to know about a parabola is they have what they call a line of symmetry. So there's kind of an imaginary line. I'm just going to dash this in here. Line of symmetry, meaning that what's on one side, you're going to get a mirror image on the other. So actually, if you look back in here in our XY chart, our vertex ended up being right here at 0, 0. And if you look off of there, it's kind of like a hub. Everything comes off of there. This goes up 1, 4, 9, and then it also goes down 1, 4, 9. And these are staying positive here because when you square, whether it's negative or positive, when you square, you're always going to end up with these positives. So that's why this thing points up. Okay? So that's the parent quadratic. Now, what we're going to look at is what if a quadratic's not in this form? What if it's in translation form? And this is something new for y'all. You may have seen this a little bit last year in Algebra 1, but we're going to get into it deeper. So, there's different components here for translation form. There's an A, an H, and a K, where the vertex is HK. So, if it's in this form, I can find the vertex, and then we're also going to use our chart here a little bit to find where the rest of the graph goes. Now, let's talk about these components a little bit. This A up here, if you'll remember, if it's positive, it's going to open up. If it's negative, it's going to open down. Now, first thing we're going to do, if you'll notice this equation right here, it looks to be in the same format as this. Okay, it looks just like this. So what we're going to do to figure out what is going on here, we're going to find out what A, H, and K are. So down here, I'm going to list A, H, and K. Now, when we look at A is in front of the parentheses, so A equals 2. H, we need to be careful. See how there's a minus sign here in the original format, the original form? Anytime you see a minus, that means you're actually going to do the opposite of what's there. So, since we have a minus in the original form, since this says negative 5, H is actually going to be positive 5. Now the K is just plus K, so it just is what it is. So since this one's negative 8, we're just going to leave it what it is, negative 8. Okay? Only because there's a minus in the original form are we doing the opposite for H. So that's the only one to be opposite of what's given up here. Now, so to find our vertex, this is our vertex, H, which we found to be 5, and K, which we found to be negative 8. So I'm going to go ahead and plot that point, 5, negative 8. So I'm going to go right 5, 1, 2, 3, 4, 5, and down negative 8, which is about right there. Now, I do know that this thing opens which way? If A is positive, which way is it going to open? Well, A is positive opens up. So, but I don't know exactly where it goes up to. So, what I'm going to do is I'm going to take this vertex and I'm going to put it in the middle of my XY chart. So I'm going to put it right here, 5, -8. That's my vertex. Uh-oh, don't do that. Are we still okay? Yeah. All right. So my vertex is at 5, -8. Now, actually, can I slide this way a little bit? Maybe not. Okay. Because it's a hub, notice up here we went to the left and we went to the right of that number. So we're going to do the same thing here. So we're going to go to the left, which would be 4, 3, going backwards, and then going forward, which would be 6, 7. And we're going to plug those numbers in to see what we get right here to see where those other ordered pairs go. So I'm going to plug these x's in to my original equation up here and see what I get for y. So I'm going to do, follow the equation, I'm going to do 2 times 3 minus 5 squared minus 8. Well, 3 minus 5 is -2. -2 squared is 4, times 2 is 8. 8 minus 8 is 0. All right, I'm going to do the same thing again. I'm going to take the 4 and plug it in for the x. I'm going to do 2 times 4 minus 5 squared minus 8. 4 minus 5 is -1. -1 squared is +1. Times 2 is 2. Minus 8 is -6. So I get -6 out of all that mess. Whether you're doing it in your head or doing it on the calculator, you're still going to get -6. Now, if I go down here, I already know that the vertex is 5, -8. So now if I plug in 6, I really don't need to, and we'll show why in a minute, but I'm going to do it just so you see it works. But 6 minus 5 squared minus 8, I'm just plugging it in. So I'm going to do the same work. 6 minus 5 is 1. 1 squared is 1 times 2. 2 minus 8 is -6. Notice that because, again, this is the vertex, everything's going to kind of come off of it. So this went -8, -6, 0. So here, going the other way, it's going to be -8, -6. And the next one, if you plug it in, you'll get 0, and you can check that. So I'm going to come back over here. Now I have enough points, I can tell exactly where that thing's going to go. And it should point up because its A was positive. So I'm going to plot 3, 0, which is right there. 4, -6, right there. I'm going to plot 6, -6. And actually, remember if this is the vertex, uh-oh, try again. Where's our vertex? 5, -8. Sorry, guys. Right there. Remember that imaginary axis kind of runs through there. I don't want to confuse you, but remember there's a axis running through there. So wherever the point is on this side, I'm going to get that same point on the other side of that axis. So I should have a point right there. And I do. I have a point at 6, -6, which is right there. This one's exactly 1 unit to the left, so this one would be exactly 1 unit to the right of that axis. So I'm going to come up here, and that one will be right there. Then I can, and if I did one more point over here, I could just put another one over here. So this is going to come up like this. Nice and pretty. Okay? So, again, our vertex is 5, -8, and then we plugged into the chart to find some other points. Now, once I have the points to the left, I know where those points on the right go because they're going to be a mirror image. Okay? Okay, guys, if you'll skip down to number 5, I want you to go back and try to do those 2 that we skipped on your own, see if you can figure those out. But on number 5, we have a little bit different form. This one is actually in root form, not vertex form. And you'll notice it does have the A, but this is different. There's no H and K and all that here. These R1 and R2 stands for root. And that's, of course, that's why it's called root form. Now, basically, you need to remember that a root, sorry guys, let me fix that. Okay. Basically, you need to remember that a root is the same thing as an x-intercept. Okay? It is also called, and actually on your calculators, it's called a 0. So all of those words are synonymous. Roots, x-intercept, zeros, all the same thing. And of course, x-intercept is where that graph's going to go through the x-axis. Now, the A here, okay, still works the same. No changes there. So if A is positive, it points up. If A is negative, it points down. But here we have these roots. Now remember how we talked about in the other form that if there's a minus in the original format, then you're going to do the opposite there. So again, you might put on there, you're going to do the opposite of whatever it says. Okay? So, oh, that doesn't look very good. Let me fix that. Try again. Talking about these negatives right here. Anyhow, okay. So when I look at this, my A is positive 2. So I know that that's positive, so I know that's going to point up. And then my root is negative 3 here in the list, but because it's the opposite, I'm actually going to put positive 3. And here it's negative 1, or positive 1, but because it's opposite, I'm going to do negative 1. So those are my two roots. In other words, those are my x-intercepts. So I'm going to come over here. I'm going to plot my two x-intercepts. I'm going to plot 3, negative 1, and I'm sorry, that is so not right. Back up. I'm going to confuse you. These are x-intercepts. So that means you have, basically what that means is you have a point at, try again. All right. You're going to have a point at 3, 0, and a point at negative 1, 0. That's what that means. So I'm going to plot those two x-intercepts, a point at 3, 0, and a point at negative 1, 0. Okay? So it's just the opposite way it looked originally. Now, to find the vertex, what you're going to do is you're going to take the average of your roots, because the vertex is going to be somewhere in between those 2 points because they're mirror image. So we're looking for that line of symmetry down the middle. So I need the average, the middle. So I'm just going to simply add, doing an average. I've done averages forever and ever. I'm just going to do the average of the roots. So R1 plus R2 divided by 2. And that'll tell me where that vertex is going to hit, at least horizontally and vertically it will. So plug in your numbers. I'm going to do 3 plus negative 1 divided by 2. Well, 3 plus negative 1 is 2. 2 divided by 2 equals 1. So that means that my vertex, and that makes sense, because if I draw a little line of symmetry right down the middle of those 2 points, it goes right through positive 1. Now remember we said we're always going to put our vertex, we're always going to put our vertex right there in the middle of the chart, so I'm going to go ahead and put at least what I know. I know that the x value is 1. I need to find where the y value is, where it goes. And really, unfortunately, the only way I can do that is to take that 1 and plug it in. So I'm going to do exactly that. So I'm going to come up here, I'm going to put in 2 times 1 minus 3. This goes right here with this. 2 times 1 minus 3 times 1 plus 1. That's just coming exactly from the equation. So when I do that, 1 minus 3 is negative 2. 1 plus 1 is 2. And I'm just going to multiply across. 2 times negative 2 is negative 4 times 2 equals negative 8. So my vertex must be at negative 8. Am I good there on my signs and everything? Yeah. So if I plot that point, 1, negative 8, it's going to be right there. Now, so if that's my vertex, that means this thing opens up. So I want to make sure, check my math. Should this thing open up? Yeah, because A is positive. So now that I've done that, I can find another point here. So an easy one to always find is when x equals 0. So let's go a little bit to the left of that hub. And so let's plug in 0 real quick, because that's going to be really easy. So if I plug in 0, I'm going to do 2 times 0 minus 3 plus 0 plus 1. Well, when I do that, I get negative 3 here and I get 1 here. 2 times negative 3 is negative 6, times 1 is negative 6. So that means I should have had a point at 0, negative 6. So that's where that thing crosses actually the y-axis, which would be right there. So again, remember, this is my vertex. So I've got 3 points coming this way now, so I'm going to go ahead and connect those things. And then I have, remember, if I got a point on the left here, 1 unit, I got a point here, right, 1 unit. So that's exactly where that thing's going to go. It'll be nice and pretty on both sides, symmetrical. So if you wanted to know, and actually we already know where it goes at negative 1 because that was an x-intercept. So we know negative 1, 0 already is in the chart. We also know the other, if we come this way, we could go back and find 2, and then, but 3 we already know is at the x-axis, so that one's 3, 0. So really the only one you have to go back and do is do the 2 to figure out where exactly that point should be. All right, I hope that helped.